Hi, I'm Lei Fan. I'm a PhD student at Northwestern University. I want to give you a 5-minute presentation of our CVPR paper. The title is Evidential Active Recognition, Intelligent and Prudent Open World Embodied Perception. The other co-authors are from Northwestern University and Wormpak's AI Research. Before jumping into our paper, I want to first talk about the task of active recognition. Active recognition is defined as the opposite of passive recognition, where the agent is allowed to move to perceive based on its own incentives. For the example here, the agent cannot make a correct prediction from the initial position, since the initial view is quite ambiguous. However, active recognition allows the agent to take movements to change to a more discriminative view. More specifically, we want to use active recognition to address the recognition challenges that cannot be resolved by traditional single-frame or video-based passive recognition methods, like heavy occlusions, out-of-view conditions, ambiguities, etc. However, the current active recognition methods, they are often equipped with a recognition module developed under the closed world setting. In other words, they assume the input image must belong to known classes. This assumption is not valid when we take embodied agents into unconstrained scenarios. For example, the agent wants to recognize the curated target in the blue box at the initial frame. However, after making some movements, the target could be missing, where the image does not belong to any known classes. That is to say, the closed set recognizer could not work appropriately for these scenarios. Therefore, we are targeted at introducing an uncertainty-aware active recognition agent in this paper. The proposed method can be broken down into majorly 3 components. The first is single-frame recognition with uncertainty estimation. We use evidential deep learning to achieve the goal of this part. The second part is how to feed single-frame prediction into the final output. We know that active recognition is a sequential process that contains a sequence of visual observations. Our evidence fusion function takes the estimated uncertainty into account. Intuitively, the final result is more likely to be affected by certain frames. The third part is about the recognition policy. In other words, the intelligent policy to predict an action to take at each time step. We use our predicted belief that belongs to the correct class as the reward for the training. Additionally, we propose a difficulty-designated dataset to evaluate active recognition, and the dataset has been made publicly available. Recall that we want active recognition to address recognition challenges like ambiguous viewpoints and occlusions. However, we do not have a dataset to evaluate the advantage of active recognition on handling these challenges. To better facilitate evaluation of active recognition in indoor simulator, we collect and propose a dataset where we give a recognition difficulty level to each testing sample. The difficulty level is calculated by considering 3 aspects, including the visibility of the target, the relative distance between the agent and the target, and the number of observed pixels. Here, I only show an important ablation study of our experiments. To introduce controllable uncertainties to our agent during testing, we add Gaussian noise to our visual embeddings. Here, the 2 figures have the agent movement steps as the x-axis and the success rate as the y-axis. We find that, regardless of different levels of introduced noise, our proposed agent with uncertainty measurements is more robust and effective. Thank you for listening. If you have any questions, please don't hesitate to contact me through my email.